Okay, let me show some problems. Okay. Now, in general, if you got a quadratic and it's asking you to find the zeros, if you can't factor it, you can always use a quadratic formula. Now, with the quadratic formula, you have to identify your a, b, and c. A is whatever number's in front of your x squared, which is 1. B is whatever number's in front of your x, which is negative 2. And c is your number at the end. Because what we're doing is we're solving this. We're solving x squared minus 2x plus 7 equal to 0. That's what finding zeros means. You set it equal to 0 and you solve it. Now our quadratic formula says we got x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. This is the first problem you're asking about, Valerie. And all I did is when you're finding zeros, if you can't factor it, then you identify your a, b, and c. A is whatever's in front of your x squared, b is whatever's in front of your x, and c is your number at the end. And then you're going to plug them into this formula. Now, it's always a good idea to go through and replace all of your variables with parentheses before you plug in your numbers. That helps reduce sign errors. Well, b we said was negative 2, so everywhere I had a b, I'll put in a negative 2. A we said was 1, so everywhere I had an a, I'll put in a 1. And c is 7, so everywhere we had a c, we'll put in a 7. Now, negative negative gives us a positive 2, plus or minus. Negative 2 squared is 4, minus 4 times 1 times 7 is 28, all over 2. 4 minus 28 is negative 24 over 2. Now, if we do the prime factorization of 24, in addition there's a negative there, so that's negative 1. We'll have 2, 4, 8 times 3. So we have 3 2's and 1 3. All over 2. Now, the negative 1 is going to come out as an I, and this pair of 2 is going to come out as a single 2. Now, we can't bring any of these out because there's just a single one of those. There's just a single 2 here and a single 3 here. So we'll have 2 plus or minus. I'm bringing this pair of 2's out as a single 2, and this negative 1 comes out as an I. I'm left with 2 times 3 inside. And 2 times 3 is 6 over 2. And whenever you have an I appear in your problem, you want to split it apart to real part separate from the imaginary part. So I put 2 over 2 plus or minus square root of 6 over 2. Oops, try it again. 2 square root of 6 over 2 with an I to the side. Now 2 divided by 2 is 1. And these 2's will cancel, and we got square root of 6i. And those would be our zeros. Here, right here. Oh, x squared minus 2x plus 7 equals 0. whenever it's asking you to find zeros, your first step is always to set it equal to 0. Oh, no, this is off of quiz 3. I think the first thing you did ask was that, but I was going to quiz 3 first. Yeah. And I just changed numbers because I can't really work anything directly off the quiz. Right. Right. You have to use quadratic formula. Did you have any? Oh, okay. Let me erase that. Now, the next one you had off of off quiz 3 was let me make up one. Like A is equal to 7 and B is equal to 5 plus I. And you wanted to find A divided by B. Well, if I put that in there, that's 7 over 5 plus I. And we can't have an I in the denominator. And when you got two items and one of them has an I in it, then how you get rid of that is you multiply the top and bottom by the conjugate of the bottom. Now, conjugate, the first part's the same, 5, 5. The last part's the same, I. But the sign in the middle is different. This is a plus, so this is a minus. And whatever we multiply by the bottom, we have to also multiply by the top. So we'll take 7 times 5 minus I. Now, the nice part about conjugates is all you have to do is multiply your first parts and your last parts. So we got 5 times 5, and we got I times negative I. Now up on top, this is a distributive property. 7 times 5 is 35, minus 7 times I is 7I. On the bottom, 5 times 5 is 25, and a positive times a negative is negative, and I times I is I squared. So we got 35 minus 7I over 25 minus, and remember I squared is always equal to negative 1, so I can replace the I squared with negative 1. Yeah, the sign, the positive times a negative is negative. That's where that negative came from. And then I times I just gives you I squared. Okay. Now, then, negative becomes positive, so we got 25 plus 1, which gives us 35 minus 7I over 26. Now, whenever you have an I, you want to split it into two separate pieces. So we'll put the real part separate from the imaginary part. So we got 35 over 26 minus 7 over 26 with an I to the side. And that's our answer. Oh, okay. Now, the next one you had was division. That's where you're taking like x to the, say, 6 minus 1 divided by x plus 1. I'll change it slightly. Now here we can use synthetic division. So with synthetic division, we take what we're dividing by, set it equal to 0, and solve. So we got x plus 1 is equal to 0. Take the 1 over, it becomes a negative 1. Now with synthetic division, we take the number we just found, and we put it in a box in the upper left-hand corner. Now we identify our largest power, which is x to the 6. So real small across the top, I'm right. X to the 6, x to the 5th, x to the 4th, x to the 3rd, x squared, x, and no x. And then I'll write down the numbers that's in front of each one of them. In front of the x to the 6 is a 1. There's that invisible 1 here. There is no x to the 5th, so that's 0. There's no x to the 4th, that's 0. There's no x to the 3rd, that's 0. No x squared, no x, and then our no x, our constant term, is negative 1. Now we're going to go through a series of adding, multiplying over and over until we come up with our answer. So I'll add 1 plus nothing's 1. Multiply, you always multiply by number up in the box, but number you put down here. Negative 1 times 1 is negative 1. Then we want to add 0, negative 1 is negative 1. Then multiply. You multiply by number in the box, but number you put down here. Negative 1 times negative 1 is positive 1. Add 0 plus 1 is 1. Multiply. Do you feel pretty good about synthetic division? Okay. So yeah, multiply, then I add. Multiply, negative 1 times negative 1 is 1. Add. Multiply, negative 1 times 1 is negative 1. Add. And multiply, negative 1 times negative 1 is a positive 1. And add, and we get a 0 there. Now, this I suspect is where you had trouble then. Now this is x to the 6, so straight down below it will be 1 degree lower. So this will be x to the 5th. Now after you have this, then you have 1 for each power going down. So this will be x to the 4th, x to the 3rd, x squared, x, no x, our constant term, and then our remainder. And you take each one of these numbers and put them in front of the x to the power. So that's like 1 x to the 5th or x to the 5th, minus 1 x to the 4th or just minus x to the 4th, plus 1x to the 3rd or just x to the 3rd, minus 1x squared or minus x squared, plus 1x or just x, and then the minus 1. And that's your answer. Okay. Let me erase that. So this last one is kind of tricky. The wording, that is. Let's see, f of x is equal to, let's say x squared plus 4x plus 8. And it says, it's asking how many times does it hit the x-axis. And we could have it look like this, where it doesn't hit at all, so that would be 0. We could have it come down and touch at 1 point, and that would be 1. Or we could have it come down below and come back up, so it touches at 2 points. Now all of this space is based upon understanding a little bit about the graph and where our vertex is. Your vertex, when your graph opens up, is your lowest point. So that right there would be our vertex. This right here would be our vertex, and this would be our vertex right here. So if we find the vertex with our vertex formula, our first step is to identify A and B. A will be whatever number's in front of your x squared, which is invisible 1. B will be whatever number's in front of your x, which is a 4. Then our second step is to plug those values that we identified into negative b over 2a. So we'll have negative 4 over 2 times 1, which gives us negative 2. Then we want to plug that value back into our original function. So we're going to find f of negative 2. So we'll have negative 2 squared plus 4 times negative 2 plus 8. Negative 2 squared is 4. 4 times negative 2 is negative 8 plus 8. Negative 8 plus 8 cancels, and we got 4. So our vertex is negative 2, 4. Now A is positive. When A is positive, our graph opens up. So if we were to sketch this, negative 2, 4 would be right here, and if it opens up, I see it's not going to cross the x-axis at all. So the answer here would be 0. It doesn't hit the x-axis at all. You could find it this way. If you set that equal to 0 and use the quadratic formula, if you end up with an imaginary number, that means it doesn't intersect at all. So that'd be a second way to do it. Okay. Now this is off of I think the number 4 self-quiz. Is that one of those two questions were that you asked about? Okay. Now this one says find the domain of our inverse. So if I look at my graph, if I look at the square root of x, that looks like this right here. And these numbers perform a certain function. When you got a number at the end, that shifts it up or down. So this says that we're going to shift it up 2 units. When your number's inside with your x, it shifts left or right, opposite what you think. The plus 5 would make us think goes right 5, so it's really going left 5. So left 5 up 2. So I'm going to go up 2, left 5, and this would be our f of x. Now it wants us to find the domain of the inverse. And this this point here is negative 5, 2. So for my inverse is going to be symmetric to this line. It's symmetric to the line y is equal to x. And it's going to be down here, 2, negative 5. Now what tells me it's going to start down there is this point here is negative 5, 2. So our inverse will be the x and y swap. So this will be 2, negative 5. And because the plus 2 here means your graph shifted up 2 units. And when the number's inside with your x, it shifts left to right. In this case, left 5. Because it's opposite of what you'd think. The plus 5 would make you think it goes right 5, so it really goes left 5. You just... Right. You see those transformations, and that tells you now the square root of x automatically looks like this. So then when I sketch this right here is going to be our inverse. And it's asking us for the domain. And our domain for this would be where x is greater than or equal to 2, because x value-wise, that's where it exists at. Now, x is greater than or equal to 2 would be written in interval notation in this manner. Now, I swear the answer that I saw, maybe it's the answer you entered, was negative infinity to positive infinity. That's you can also do it that way, but in addition to what you were doing there, you'd have to still go back to your graph to help figure out what your domain is. Mm-hmm. Right. Exactly. It's mainly because of the picture. Like if you look at this right here, you see that the blue, your inverse, does not exist anywhere over here. It doesn't start until x equals 2. That's why we know it's x is greater than or equal to 2. Oh, no. To figure out the domain of your inverse, usually the graph is the easiest way. Now, I probably should have showed number 5 first, then that would have made more sense. But do you have any other questions on that one? Yes. If I come here and I put my square root of x plus 5, so I do second x squared, x plus 5, and then closing parentheses, and then plus 2. Now this is what our graph would look like. And this is what I showed you with the black right here. To draw the inverse, there's a draw menu. You see above your program it says draw. So if I do second and click this program right here, then there's a draw inverse. I'm going to do an up arrow to get to it fairly fast. And if I do draw inverse, I have to tell what I want to draw the inverse of. So I go to my vars, and then I want to go to my y vars. Then I'll go to my function, and then I choose y1. Did you catch all that? If I press enter on this, yeah, they should. See, that's over here where I drew my blue. They should intersect on the line y is equal to x if they are going to intersect. That's legit. That shows an understanding of what is inverse, what is a symmetric do. I don't know. I know you can do trace, but I'm not sure how to tell it to trace the second graph. Okay. Yeah, I don't think they'll put so many problems, like you say, close enough where you can't tell exactly which one it is just by looking at it. Now this other one, if we have f of x is equal to x squared minus 4, where x is less than 0. And it's asked us to find the inverse. Now our first step is to replace f of x with y. So we got y is equal to x squared minus 4. Now step 2 is to interchange your x and y, swap them. So we got x is equal to y squared minus 4. And then step 3 is to solve for y. So we want to get y by itself. First off, I take the negative 4 over. So we got x plus 4 is equal to y squared. Now we have our square root property. And square root property says if you got something squared equal to something else, you drop your squared, and you put a plus or minus square root around the other side. Now, we're going to really focus on this line right here in a minute, but I'll come back to that. Step 4 says to put your inverse notation in. So the inverse of f is going to equal to a plus or minus square root of x plus 4. Now, if you watch that video that I created, one thing it told you couldn't have is that you can't have a plus or minus in here. And step 5 says to use your graph to help figure out how to make this one-to-one. So let's look at our graph first. We got x squared minus 4. Now the minus 4 means I'm shifted down 4 units. And so our graph would look like this, more or less. Now, when we're saying that we want to look at it where x is less than 0, well, here's x equals 0. And to say we only want the part where x is less than 0 means we're erasing the right side and keeping just the left side, because this is where x is less than 0. So that's our f of x. Now this is starting at negative 4 on my x or my y-axis. So this will start at negative 4 on my y-axis. Because this point right down here is 0, negative 4. So our inverse is going to start at negative 4, 0. Because the x and y swap. And if I sketch this, it'll look like that. Now how I get to sketch, if I take this little piece right here, you see what I'm highlighting, if I flip that across this line, that'll give me this piece right here. If I take this upper piece right here that I'm highlighting, if I flip it across this line, it'll give me this piece right here. Is that good on the graph? Okay. Right. Well, the constraint, whenever you have a plus or minus, you're either going to drop the plus or you'll drop the minus. Now, remember how I said we're going to be looking at this step a little closer? This says y is equal to plus or minus. Now, look down here. What are my y values down where this blue graph is, the inverse of f? Are they positive or are they negative? Negative. So the sign I'm going to keep is the negative. So whenever you have the plus or minus, you drop one of them to decide what to keep. Now another way you can do that is, you see how this is It says x is less than 0. Then for our inverse, we're going to have y is less than 0 because the variables swap. So y is less than 0 means it's negative, so that's why we keep the negative. Now they'll throw something additional on here. They'll say x is going to be greater than or equal to -4. And they're not putting that on there to make it one-to-one. They're putting that on there for the domain. Because if I take what's inside the square root, set it greater than or equal to 0 and solve, we get x is greater than or equal to -4. So this right here would be your total answer. Yes. In this case it does. It won't always, but with the way this is set up, it ties directly to that. Yeah. Normally I don't like the graphing part. I like algebraic ways to do it, but the graphing is actually the easiest to see. Yeah, sometimes reading math notations is a little bit difficult. Right. Yeah, with my memory I needed to do that. I don't think I have the... If you look in the syllabus, if it'll be anywhere, it'll be in the syllabus. And I don't remember, to be honest. Well, good. Okay. Well, have a good afternoon then. Oh, that's no problem at all. Night.